My name is Dr. Stephen Sammut. I work at Franciscan University. I'm a professor at Franciscan University. I'm actually a neuroscientist, and my area of research and area of interest is animal modeling in psychiatric disorders.
Well, we're delighted you could take the time to talk to us, and without further ado, let's just go ahead and get into your presentation.
Thank you so much. I would like to thank the organizers for giving me this opportunity to share the research that I'm currently conducting. So today I'm going to be talking about the utilization of animal models in the investigation of pregnancy-related scenarios. Specifically, the research I'm going to talk about, which is the research I'm conducting in my lab, is the investigation of abortion and ectopic pregnancy. If we could go to the next slide, please. So the first project I'm going to address is the abortion study. This is, in more detail about this, is that it's the drug-induced pregnancy termination at first trimester human equivalent in an animal model. Yes, this is a mouthful, and I'm going to break it down for you. Next. This research has actually been published. Was published in Frontiers in Neuroscience, and the title we gave it for the paper, in order to be as explicit as possible in terms of what we were actually researching and addressing, is the biological, behavioral, and physiological consequences of drug-induced pregnancy termination at first trimester human equivalent in an animal model. Next. So the presentation outline, I am first of all going to break down the title for you. What does it all mean? Yes, like I said, it is a mouthful, but I'll explain that aspect. I'm going to give you the background and the rationale for the study, the results, explain the implications of the results, and then talk about the relevance to humans as well as future direction. So let's break down the title. Biological. Biological is a measure of the general well-being closely associated with survival. So that's the aspect that is described by the term biological in this sense. Behavioral is because we're measuring behavior. Physiological, because we're measuring some subtle physical changes in the workings of the organs, including some measures in the serum and the liver, as you'll see. Drug-induced pregnancy termination, that's what we're utilizing in order to induce the abortion and in order to mimic what takes place in human abortion utilizing these drugs. First trimester human equivalent, we're doing this in the rat, but in the human, it is equivalent to the first trimester, And it's an animal model, and that's what basically the whole title stands for. Next. So what are the types of abortion? Methodology, basically how it's done. There's chemically or drug-induced medical abortion, which is becoming more and more common, and then there's surgical. So those are the two major distinctions in terms of methodology. And then in terms of the other aspect of distinction is the time in gestation when the abortion is done. There's early term, mid-term, late term. The drug-induced tends to be used earlier. Late term tends to be more surgical. And unfortunately, we are now seeing the use of the term post-birth abortion, which really is not an abortion, but it's infanticide. However, because of the acceptability of the term abortion, infanticide, when a child is actually born and ultimately killed, it has been referred to even in scientific papers as post-birth abortion. Next. The consequences of abortion in humans have been widely debated for many years. The consequences reported include, but are not. This is not as a full summary of all of them: mood disorders, anxiety, substance abuse, suicide, depression. However, we lack objective physiological and behavioral data. Now, I want to clarify what I mean by that aspect, because you may be thinking, well, epidemiological and psychological studies have been conducted. Yes, and obviously they're as legitimate as anything else, any other research, if they're done properly. So the distinction when I say objective, lack of objective physiological and behavioral data, I'm making the distinction between those kinds of study, the epidemiological and psychological, where we're observing human behavior, where obviously human feelings, etc., can play a role into it, versus the basic science experiments, the preclinical aspect in animal models. I actually want to point out something here on the slide. Um, Interestingly, so I order the same drugs that are utilized in humans. Obviously, I order them for the standards that are required for the experiments that I conduct. However, it is really interesting how the label of the drug, the mifepristone, RU486, which is the drug that induces abortion, has as a warning on the label itself, may damage fertility or the unborn child. So from a scientific perspective, when I see this kind of thing, it is somewhat disturbing that we are admitting, or the label admits, that this is an unborn child, and yet obviously abortion continues unabated. Next. With regards to the rationale of the study, well, pregnancy is a normal physiological process. It involves significant hormonal changes. The body has to obviously prepare for the acceptance of the new life that is in the womb. Pregnancy involves significant alterations in the body, including through the HPA axis, the hypothalamic, pituitary, adrenal axis. This system in the body is so fundamental that it affects the stress system, it affects the immune system, the neurochemical system, the electrophysiological system. So in affecting all of these systems, it affects the way we ultimately behave. Therefore, excuse me, as a result, we would expect that if pregnancy involves all of these significant changes, that terminating a pregnancy through a chemical or surgical means could potentially induce physical changes, for example, in the brain, and even behavioral changes as a result of those physical changes, such as potentially depression-like or depressive behaviors. Next. When I talk about animal models, we're not talking about animals that are strutting down the aisle, all dressed up in something. When we're talking about animal models, we're talking about animals that are utilized to model human uh, pathologies, basically. So what are they and how do they help? First of all, the use of animals is significantly regulated. There are so many rules that regulate animal use. I have to say that unfortunately, from my perspective, to some extent, it is somewhat disturbing that you feel sometimes like there are more regulations addressing the appropriate use of animals in research than there are in terms of the ethical treatment of humans in research. Obviously, but in both cases, both should be treated appropriately and ethically, whether it's an animal or a human. However, that's the state of the situation as we see it. So, animal, as we see it in our current society, animal models date back centuries. They they're independent of potential social, moral, and other influences, and that's one of their pluses. They're also possible because of the similarity in physiology. They are key to the understanding of human pathophysiology and psychopathology, as well as the advancement in human medicine and drug discovery. They link the lab bench research to the patient. And it has to be understood, despite our confidence in what we see and what we observe, we have to understand that no animal model is a perfect replication of the clinical model. So that aspect, that limitation needs to be always understood, be it me presenting to you here, or even if I was writing a paper. And in fact, one of the major requirements in papers these days is the addressing of limitations. Next. So how do we make sure that what we're seeing makes sense? Well, there's internal and external validity. Internal validity refers to the fundamental integrity of the experiment, the experimental design, reproducibility, randomization, and having the appropriate controls. Then there's external validity. McKinney and Bunny, later it was expanded by Wilner, proposed three primary criteria for external validation. This is construct validity, which is the etiological, the cause of what you're observing. Phase validity, which is symptomological, so similarity in symptoms. and then predictive validity, which is the therapeutic aspect, the treatment of what you're seeking to address. Next. So the subjects, now getting back into the experiment itself. The subjects, all experiments, experimental procedures met the NIH guidelines for the care and use of lab animals. Our protocols were approved by the Franciscan University of Steubenville, Iowa. That's the Institutional Animal Care and Use Committee, okay, which addresses the ethical treatment of animals. We utilized female Long-Evans rats. These rats are single housed at 9 weeks. They are on a 12-hour light dark cycle. They are under controlled temperature and humidity, and they have continuous access for food and water, aside from the hour that they are being tested. Uh, going to the upper right, you see the groups that are utilized. So starting on the bottom right-hand side of that diagram, you see D minus P minus. D minus P minus stands for receiving vehicle. Okay, even the rats that don't receive drug, they still have to be injected and they receive the vehicle. And P minus meaning not pregnant. So this is the true control here. These rats are not treated with drug and are not pregnant. Moving up, we see the D plus P minus. This is the group that receives drug but is not pregnant. And this enables us to look for the effects of the drug itself in the absence of pregnancy in order to be able to separate those effects. Moving to the bottom left-hand side, we see D minus P plus. D minus P plus, this is the group that receives vehicle and becomes pregnant. So this is the group that will carry the pregnancy to full term. And D plus P plus is the group that receives drug and is pregnant. So this is the group that I call the abortion group. Next, please. The chemical termination, some more details here regarding the experiment. So the rat gestation is 21 to 23 days. Now, I've met women who have told me, oh, I wish pregnancy was that short for humans. But realistically speaking, you need to keep in mind when you're talking about this, that 21 to 23 days in a rat is about a year and a half in humans. So I don't think people would want to go there. When it comes to the drugs that we administered, we utilize the same drugs that are utilized in humans, mifepristone, misoprostol. Mifepristone is a progesterone antagonist and is causes the pregnancy to end. And misoprostol is a prostaglandin agonist that causes the contraction of the uterus in order to cause the expulsion of the baby. The dosing that we utilized was based on various scientific literature. We utilized midterm termination. And midterm in the rat is equivalent to the first trimester human, okay? Midterm in the rat is first trimester human. So that's an important aspect to keep in mind in terms of relevance to what we're observing in society. The administration of the drugs took place on day 12, 13, 14 of gestation. The misoprostol was administered on the last day, and the rats in the control group were administered the vehicle on the same days. Next. So we start by looking at the behavior now. Next. We measured body weight. Body weight is a measure of health and well-being. In humans, under stress, we see weight gain or loss, depending on the situation. In rats, we see weight loss, and this has been reported under the effects of stress. Food weight, food intake, we see is also a measure of health and well-being. In humans, we see changes in food intake, and this is dependent on the stressor. In rats, we also see changes in food intake, and it depends on the stressor and as well as the intensity. So mild tends to cause no differences, while moderate and severe causes a decrease in food consumption. Next. We also measured vaginal impedance. Now, this is a measure that is an indicator of the point in the estrus cycle of the rat. Peaks indicate fertile periods, and you've got to keep in mind that the estrus is equivalent or similar to what we would call ovulation in humans, and there's an increased sexual receptivity that is observed in the rats. Their cycle is generally about 4 to 6 days approximately, and what you're seeing in the bottom diagram there is a normal cycling of a rat's cycle. So you see the peaks where they would have been fertile, and then on the very last cycle, we bred the rat, and you don't see any further peaks because the rat became pregnant. Next. Other procedures, we measured sucrose consumption or sucrose preference. A decrease under stress conditions has been reported in the previous literature, and there's extensive literature in this regard, as being indicative of anhedonia, which is the loss of interest or pleasure. And it's related to the diagnostic criterion for depression in the DSM-5. Now you can see how I'm going to be making these relationships to human criterion of diagnosis. Okay, and this is important because ultimately the work that we are doing is being done in order for us to understand better what is happening in the human. Actually, having said that, one aspect that maybe I did not even mention when I was talking about animal models, one of the reasons why we can utilize animal models is because of the similarity in especially neurocircuitry and natural behaviors that are observed in animals and humans. But certainly the neurocircuitry is very similar between humans and, speaking about my model, the rat. We measured locomotor activity. This is all a measure of exploratory behavior. It includes rearings when the rat stands on its hind legs, the distance traveled, the percentage time active, overall speed, the time spent in the cage, the cage corners during the testing. In humans and rats, a variety of effects have been reported following periods of stress or depression. This is related to the DSM-5 criteria of reduced physical movement in depression. On the right, what you see at the top right, that's the cage that is utilized in order to measure this activity. Actually, you may see bottles hanging there. Those are the bottles that are utilized for the sucrose consumption. And then the beams, the black bars that are going across, those are actually infrared beams that monitor the activity of the rat as it moves around the cage. The information that's shown on the bottom, that's more for, if you want a pretty picture kind of, that's more, it shows the activity of the rat within the cage. The red crosses are areas where the rat stood up and reared. So that's an indication of that. Looking at it that way is pretty much meaningless. There's extensive analysis and analysis by the program and then post hoc after the program has done it in order for us to obtain the useful information that we utilize. Next. We measured home cage activity. We had some subjective observations. We care for our animals ourselves. And obviously, when you walk into the room, you're aware of what's going on with your animals, or you should be at least. And we certainly are. And we observed that there were certain things that did not look right with regards to the rats that had the abortion. So we devised a way where it was not based on subjective observation, but clearly objective measures. So the subjective observations led us to investigate this more objectively. And this is a measure of general activity as per locomotor activity. And it's related again to the DSM-5 criteria of reduced physical movement in depression. We also utilize the forced swim test. And this looks at immobility. And you see that an image of that. The rat is placed in a tube filled with water. Rats are natural swimmers. They're not going to drown. They will swim around in order to stay up. And it's a 5-minute test. This is a standard test that is used to measure what we call in humans the equivalent of behavioral despair. It's a standard test for preclinical testing of antidepressant efficacy. However, there's also problems with it. Various effects of stressors have been reported. So some studies have reported a depressant effect, some have reported an antidepressant effect, some have reported no effect. And that's something that's just out there in the literature. Next. So we'll move on now to the behavioral, now the results. Next. This, on the top, left-hand side of the slide, you will see what is being measured. I hope that this makes it somewhat easier because there is technically a lot of data in each of these graphs, but I'm going to summarize each one for you. So basically what we see is the green triangles, upside down triangles, the light green triangles that keep on increasing. Those are the rats that became pregnant, remained pregnant, and gave birth naturally. They continue increasing until they give birth. On the other hand, the dark green triangles, those are the rats that had the abortion. So their weight increases until we start administering the drugs that induce the abortion, and then decreases and decreases significantly, even below the control group, the control rats that are the D minus, P minus, the red circles, and the D plus, P minus, the orange filled circles. One other aspect I wanted to mention here is that we look at percentage weight change. Okay, please look at the axes labels in order to ensure that you're understanding what is being measured here. So the take-home message from this is that the rats that had the abortion lost significant amount of weight following the abortion, to the extent that they dropped well below even the control groups. Next. The interesting aspect, so the orange circles and the dark red circles, those are from the last slide. However, we had a situation where we had some rats that were naturally miscarrying. Obviously, you can't plan a natural miscarriage. Coincidentally, we're making the same measurements for them as we were making for the abortion rats. What was interesting is that the rats that had a natural miscarriage, that's the upside down light green triangles, the miscarriage group, did not show the same weight loss that the abortion group did. This is indicative that the weight loss that we are seeing is not because they have somehow expelled the babies, because rats don't necessarily do that. There's some resorption that can take place of the embryo, of the fetus. What we saw here is that the rats that had the natural miscarriage seemed to then stabilize at the weight where they lost their pregnancy naturally. There is a slight decrease, but there was no significant change in the days that are shown there. Next. Looking at food weight. When it comes to food weight, we measured percentage food weight. And the reason for this is a big rat will eat more than a small rat. So in order to normalize it, we looked at the amount of food that is eaten as a percentage of the rat's weight. Again, what we observe here is a significant decrease in food consumption. They pretty much go close to zero. Many of them are at zero. In the rats that have the abortion, we do see some drug effect, drug alone effect, and that's the orange circles. However, the most outstanding significance and differences that we observe are clearly in the rats that have the abortion. Next. Again, we were measuring this in the rats that miscarried. Now, interestingly, what we see there, now keeping in mind that food weight, what they eat, is an indicator of general health of the rat. We see a decrease in the abortion group, okay, as I showed you in the previous slide. However, the rats that were pregnant, their food consumption is stable as a percentage of their weight. And the rats that had the miscarriage also showed a similar stability as the rats that had the pregnancy and carried it to term. I'll explain this in more detail and the implications of this a bit later on. Next. We measured vaginal impedance, as I indicated. One interesting aspect in this is that we know that naturally humans and animals in general, as we age, in females, there is a reduction in fertility. So the rats that this is the pre-breeding and post-breeding at the end of the experiment, we see a reduction in vaginal impedance, which is an indicator of fertility in all of the groups except the group that had the pregnancy and carried it to term. And this is something that says something with regards to the importance, what pregnancy does, a protective effect, as I'll talk about later, of pregnancy. Next. With regards to sucrose consumption, whether we look at it within the week or between the pre-treatment and post-treatment week, comparing, pre-treatment and during treatment, the treatment week, we see a significant reduction in sucrose consumption only in the abortion group. Next. With regards to rearings, we see a significant reduction only in the abortion groups. We see some reduction in, but not significant, in the pregnancy, in the pregnant rats. However, that is not surprising. At this point, when this is being measured, the rats are starting to get larger with their pregnancies. So as they get bigger, they tend to move around. But it's not because, even visually, as you're caring for these animals, you'll notice the difference between a pregnant rat that's not moving around so much because she's getting bigger versus a rat that had the abortion. Next. I've got three graphs in this slide, but that's because they're all related. We know that distance, speed, time, those are all related. Okay, so this is looking at locomotor activity, and in all cases, we see a significant decrease in locomotor activity in the rats that had the abortion. Next. We measured the activity in the cage that they were being tested, but then we split the cage into corners. Now you'll see, we all know that a box has four corners. So you may be wondering why I measured. We're comparing three corners here. The reason for that is because the corner that's labeled there, the northwest corner, which has the bottles, because of the bottles, it makes it very difficult for the rats to actually enter that area. So that causes significant, to include that data, it would significantly skew and distort the analysis of the data because they spend so little time in that area. So we measured the three corners where they spent most time, which is greater than or approximately 95% of the time: the southwest, southeast, and northeast. Now, the rats that had the abortion spent most of their time in the southwest corner. There is significance, relevance to this, and because that is the corner that is closest to the back wall and furthest away from open space. Keeping in mind that for an animal, for a rat, the open space is a threatening environment, if you want to call it that. So they will seek to investigate it less, and most especially in situations where they're not functioning properly, as I'll explain. Next. With regards to home cage activity, again, we noticed significant differences in the rats that spent the most time immobile were the rats that had the abortion. We made this measurement 3 days postpartum. Now, I want to clarify this aspect. So 3 days postpartum for the abortion rat is day 17. Day 14 is the last injection that they get, and then day 17 is the third day postpartum. It's measured from when they gave birth. The gave birth being they had the pregnancy was terminated. For the rats that carried the pregnancy to full term, their third day postpartum is 3 days after they gave birth. Now, we see some increased mobility in the rats that gave natural birth, but there is a significant difference, and you can see this even in the images I show you there, in the rats, because the rat that had the abortion is huddled in a corner, arched back, coat is unkempt, and those are all indications of the rat not being well. Whereas the mother that just gave birth is actually immobile because she's nursing the babies. So there is a very clear distinction as to the reason for the immobility. But again, still, even with that, taking that into consideration, the rats that had the abortion had the greatest amount of inactivity. Next. So now some information regarding the biochemistry. Next. This is some background. So oxidative stress is stress at a cellular level. Oxidative balance is used as a biochemical marker for oxidative stress. It's altered in situations of stress and depression in animals and humans. Animal models of depression show an increase in oxidative stress in blood and brain and a decrease in antioxidants. Antidepressants correct this imbalance, and this has been observed in depression. In our study, we measured oxidative balance in the brain, liver, and serum. Next. So here's the results now of the biochemistry. Next. So pregnancy and oxidative stress. Let's clear this up. Oxidative stress can be damaging to fertility. It's reported in miscarriage and other pathophysiologies. However, an increase in oxidative stress is beneficial for successful pregnancy to occur and be maintained. And this is due to the cellular adaptations in the blood that offer protection from oxidative damage. The main changes that we observed were in the serum, and we observed changes due to drug alone, we observed changes due to pregnancy to full term, and the abortion group was different from both of these groups. Now keep in mind that the abortion group was pregnant and did receive drug, but it was different to drug alone and pregnancy alone. The analysis, bringing together all of these results and conditions, basically showed that abortion was a significant predictor of the negative behaviors that were observed. Next. So what are the implications of all this? Next. On the left-hand side, you'll see a summary of what we found, and on the right-hand side, you see the implications. So our findings in the rats indicate that medical abortion, as it is also called, at a time point equivalent to the first trimester in the human, induces significant negative changes in body weight and food intake. This is a reduction in overall well-being, a significant reduction in sucrose consumption. This is an indication of anhedonia, which is the inability to experience pleasure, and this is reflective of the depression-like behavior. And notice I refer to the DSM criteria. A significant reduction in sucrose consumption during the treatment week, and that's the same reasoning as the one I just mentioned. Next. We observed significant changes in behavioral aspects that relate to distance in terms of activity, so percentage time active, overall speed, and rearing. And this is indicative of potential significant stress and depression-like behavior. We observe significant reduction in overall home cage activity. Again, the implications are the same here. A significant increase in time spent in the far back corner of the testing cage. Now, this is potentially an indicator of an increased sense of anxiety. Next. We observed a significant reduction in the amplitude of vaginal impedance peaks. This is in contrast to rats that carry the pregnancy to full term. And this is potentially reflective of a reduction in fertility and an absence of the protective effects of pregnancy and delivery. The differences in oxidative balance indicate effects that are distinct from those of pregnancy and drug administration alone, as I addressed earlier. And the significant differences from natural miscarriage in the body weight and food intake indicate that the observed effects are specific to the induced abortion and not just loss of pregnancy. Okay, so there's a distinction between natural pregnancy loss versus drug-induced. So how and why does this apply to humans? Animal models of stress, depression, anxiety have been established preclinical models for investigating human psychopathology and even drug development. Our observations following pregnancy termination indicate a moderate to severe stress related to the abortion. Now, keep in mind, the standards in terms of definition of moderate to severe stress are not being set by me. These are documented in the literature, and we cite these appropriately in the paper, of course. Abortion-related effects are present several days beyond the termination, and this is distinct from being present only during the application of the stressor. Okay, so the abortion-related effects were present several days after, beyond the termination. So that being the stressor, which is in contrast to the behaviors, the negative effects being observed only during the application of the stressor, as per previous other literature. The effects are not as short-term as they may be. Rat time is not human time. The effects on food intake, which are clear over at least 7 days in the rat, equivalent to approximately 244 human days. The biochemical observations that we made are still visible at the end of the experiment, which is approximately 70 days from the treatment week, from the termination week, which equates to approximately 6.5 human years. And we're talking about here the biochemical differences. Next. So what do we do with all of this information? Potentially provides us with a scientific basis for what is observed in humans. It also shows us the necessity and importance for additional research with regards to the consequences of abortion in humans, not just addressing it from a moral and a philosophical aspect, but also understanding that there are physiological consequences that could potentially be causing the behaviors that we observe in humans. Next. The future direction. Work that we're currently conducting in our lab at the moment addresses two aspects. First of all, we observe the behaviors. So now we need to understand what is the background of what's the reason behind those behaviors. So in order to do that, we will be conducting neurochemical and electrophysiological measurements in the brain in order to address the potential changes that could potentially lead to these abnormal behaviors that we're observing. The potential dysregulation in communication between the upper brain and the lower brain is crucial for us to understand, because this is basically the fundamental underlying concept that underlies all psychiatric disorders, an imbalance between the upper brain and the lower brain. We also are going to, hopefully, once this is done, also address other relevant behaviors observed in humans and potentially related to the same neurological effects of abortion, such as, for example, the relationship to substance abuse. The other aspect that we are addressing is the abortion, drug administration, and reversal. So there is the possibility, and this has been shown at the clinical level, of a woman regretting an abortion shortly after taking the pill and being able to reverse it. And this is one experiment that we are doing at the preclinical level as well. Next. So I've talked to you about the abortion study, now the ectopic pregnancy study. In this, I would like to thank the American Association Pro-Life OBGYNs, who have been a great support and in terms of even consultation in this regard. I am obviously not an OBGYN, I'm a neuroscientist, and I depend on people who are addressing human situations in order to help me and guide me and inform me. And I would also like to thank Christina Camilleri, my research assistant, as well as Dr. Kara Buskmiller, who is an OBGYN participating and assisting us in this project. Next. The goals of this part of the presentation is to understand the role of animal models in providing us with the possibility to investigate human pregnancy, to understand the limitations of the preclinical studies in assisting us with our understanding of human pregnancy, to understand the necessity for such research and its goals, and to discuss the preliminary findings that we have thus far. Next. So what is ectopic pregnancy? It is obviously very difficult. Ectopic pregnancy occurs in various types in humans. Let's address that aspect first. The most predominant form is tubal, which makes up for about 90 to 95% of ectopic pregnancies. Ectopic pregnancy is a major cause of maternal death in the first trimester, and there are various conditions that are associated with an increased risk of developing ectopic pregnancy. And these include sexually transmitted disease, pelvic inflammatory disease, and the use of IVF. In humans, ectopic pregnancy are often diagnosed early in pregnancy. On the other hand, ectopic pregnancies are rare in animals, and the most common ones that are observed tend to be abdominal. Next. The diagnosis of an ectopic pregnancy is a difficult one. Obviously, it's difficult for the mother in whom it's diagnosed, most especially if the pregnancy is desired and long awaited. Difficult for the father, for the whole family. However, it's also difficult for those supporting the family, the doctors. Currently, the procedures available result in the loss of the embryo. It is important to note, however, that there is a key distinction in the case of ectopic pregnancy relative to elective abortion. This is foreseen and unintended loss of the embryo, resulting from an action taken to remove pathological tissue. The National Catholic Bioethics Center, in a document issued in 2013, presents 4 protocols for the managing of ectopic pregnancy: expectant management, salpingectomy, salpingostomy, and methotrexate. Expectant management is, as the name implies, the monitoring of the ectopic pregnancy in the hope that it may resolve itself. Interventions are taken if this does not take place and the mother is at an increased risk. Salpingectomy involves the removal of the whole or part of the affected fallopian tube. Salpingostomy, on the other hand, involves the longitudinal slicing of the fallopian tube and removal of the embryo and damaged tissue. And then finally, there's methotrexate that can be utilized to target trophoblast and as a result cause the death of the embryo. Now, I have remained intentionally vague in my descriptions as I wish to avoid any delving into the intricacies involved in these procedures and cause ethical arguments and disagreements. This is because it's not the scope of my presentation here with you to address the ethical pros and cons of these techniques. Of course, the best scenario we would love to see is the situation where we would be able to surgically transplant the embryo into the uterus following the mother, allowing both the mother and the baby to survive. Next. So the question is, can this be done, or has it been done already? Well, let's start with the problematic one. Pierce in 1994, this was a study that claimed to have conducted an intrauterine relocation of an ectopic pregnancy in a 29-year-old African woman. However, in 1995, the British Journal of Obstetrics and Gynecology issued a retraction of the study and other studies by Pierce. The retraction claimed that following an investigation conducted by the St. George Hospital Medical School in London and an inquiry by RCOG, the Royal College of Obstetricians and Gynecologists, it was concluded that the content of both the article and the case reports written by Mr. Pierce are unsubstantial and should not be relied on. These were not the only articles retracted. 23 papers were retracted based on the fact that they found no evidence that the studies had even been carried out. Then there's the Wallace paper in 1917. So this is a case study of a 27-year-old patient. She was being operated for the presence of a fibroid when an ectopic gestation was discovered in the left tube at the outer part of the isthmus. Following the removal of the fibroid, the tube was opened, the intact pregnancy and part of the tube wall were carefully dissected and placed in the uterus and sutured in the wall. Following surgery, the patient was monitored and discharged after 14 days, and the woman is reported to have given natural birth to a boy. The time point of the pregnancy when the procedure took place appears to be approximately 50 days. Next. A more recent case is Shettles, which reported the report that was published in 1990 based on a case that took place in 1980. In this case, the patient was a 27-year-old woman admitted to hospital for severe pain in the left fallopian tube area. The abdominal pelvic exam did not reveal any remarkable observations. They proceeded then to explore under regional anesthesia, where a single course luteum was discovered in the left ovary and a 4 to 5 millimeter mass in the left tube. Shettles reports that an incision was made, then the intact embryonic sac removed. The tubing was inserted into the myometrium and the embryonic sac attached and placed in utero. A normal infant was delivered at term. The time point of the pregnancy when the procedure took place seems to be around 40 days. However, despite these cases, there remains no reproducible medical procedure for embryo transfer. And next. And this is where we come into the whole aspect of preclinical studies and animal models. Next. So why do we need preclinical studies? The concept of first do no harm needs to be kept at the forefront of our mind as we go forward. I take the liberty of going into some depth in this aspect because we live in a society where, unfortunately, the attention to ethics is something that is secondary rather than primary. So first and foremost, we have the mother to consider, but we also need to see what can be done to save the baby. Let's consider first the possibility of conducting such research in humans. There are many ethical issues with this. The foundation of what I'm about to share with you should have been common sense and basically a respect for human dignity. But common sense is most often lacking. It seems we saw the abuse of the Jews by the Nazis, and following that, at the end of the war, there came the Nuremberg Code. An interesting observation I have to share is how, with time, things have become more verbose. You look at the Nuremberg Code, and it's about 2 pages long. You look at the code that we have now, the codes that we have now, and they are so much longer. I think as we progress and as humans, I think we regress potentially when it comes to our capacity to understand. So from the Nuremberg Code came the Helsinki Declaration in 1964 with the various edits, and the latest one being in 2013. And the Helsinki Declaration states that medical research involving human subjects must conform to generally accepted scientific principles, be based on a thorough knowledge of scientific literature, other relevant sources of information, and adequate laboratory and, as appropriate, animal experimentation. Of course, as the statement suggests, the welfare of the animals does need to be respected also, and that's why there is an oversight in the form of an institutional animal care and use committee, the IACUC. Aside from the ethical aspect, this is necessary also for the integrity of the experiment being conducted. The IACUC and the oversight of animal uses, that's what I'm referring to here. In the same way that no stressed human being functions normally, no stressed animal functions normally. Additionally, the Helsinki Declaration continues to address the fact that if an unproven intervention is utilized, it needs to subsequently be made the object of research designed to evaluate the safety and efficacy. Next. From the Helsinki Declaration, we now move to the Code of Federal Regulation, Title 45, Public Welfare, the HHS, Part 46, Protection of Human Subjects. And again, I show you all of this because I want to show you that the rules exist. People just need to follow them. Title 45 of the CFR Part 46.204 states that pregnant women or fetuses may be involved in research if all of the following conditions are met. That's my emphasis. And there are 10 conditions listed from A to J. However, it is sufficient to just see condition A, which indicates the necessity for preclinical studies where appropriate. It states, where scientifically appropriate, preclinical studies, including studies on pregnant animals, etc. Okay, so you see it there. And this is where our study comes in. Next. So what should a preclinical study consider? What should such a study need to consider? An experiment pertaining to ectopic pregnancy at the preclinical level needs to consider the following criteria: the survival of the mother, the reproductive of the health of the mother after the procedure, the survival of the embryo, and then the long-term health of the embryo. Pertaining to the last point, being able to do something does not mean your job is done and your job is over. You need to understand the repercussions of what you did. In this case, realistically, we have two things to consider. Obviously, the fertility of the mother post-op, and also the long-term consequences on the offspring because they underwent, the mother underwent a significant surgical procedure while they were in utero. Next. So now, so with regards to pregnancy and the rat model, it's beyond the scope of this presentation to go into all of the various details of similarities and differences between the rat and the human, but suffice it to say that previous research has indicated that the rat is not a good model for early implantation, but that the rat is an appropriate model for studying the mechanisms of decidualization, the uterine tissue remodeling that takes place during pregnancy, and the fetoplacental development. Next. As you can see from this image, the rat's uterus is bicornuate. Okay, there are two horns, as we call them, two uterine horns. This offers a practical advantage, especially in the experiments that we are conducting and what we are seeking to investigate. It allows for the possibility of treating the two uterine horns separately. This is something we are seeking to capitalize on in the study. An important consideration that we are keeping in mind as we conduct our experiments are that both distension and hormones are necessary for the vascular changes that take place. Next. I include this slide in order to give a better understanding of what a pregnant uterus looks like. The fetal bulges are labeled as well as the vasculature that are clearly visible. Next. This now brings me more specifically to our study. I need to address an important point here. We are not seeking to create an animal model of ectopic pregnancy, so I'm not seeking to induce an ectopic pregnancy. The goal of the study is to seek to investigate the possibility of providing a foundation for a surgical technique that would hopefully then be adapted to use in humans for the transfer of the embryo, in such cases as an ectopic pregnancy. So while for short, I do call the study the ectopic pregnancy study, I want to ensure that the true goal of the study is clearly understood. Next. The goal of the initial aims these aims contribute to the aspect I addressed earlier pertaining to validity, specifically the internal validation. So this means that unfortunately, if you want to call it that, I don't. I call it doing things properly. There's a necessity for laying the appropriate foundation for the work. The necessity for internal validity requires us to ensure that we have an appropriate understanding, a background of the conditions that will then be required when a transfer is attempted. With this in mind, aim one sought to investigate the vascularization and the sensibility of the postpartum uterine horns. This is the research in this case is done, and the manuscript is currently being peer reviewed. In aim two, the investigation of the vascularization and distension of the pregnant and barren uterine horns during pregnancy. And then aim three. Aim three, I'm not even going to read through what it is, because we actually ended up, because of the previous results from what we've seen in aim one, aim two, we are scrapping aim three because it does not really make sense for us to do it. And this is where the appropriate utilization of animals comes into it, because you should not conduct experiments if what the data that you've collected is showing you that that aim is unnecessary. So we're going to be proceeding beyond aim three into looking at possible surgical technique now that could potentially be utilized and improving it in vivo. So the findings of all of these aims will contribute to the future aims that I will address later. Next. Aim one. So I've placed the aims at the top of the slide so that they're there. So investigation of the vascularization, the sensibility of the postpartum uterine horn. Aim one was necessary because it provides us with information pertaining to the long-term persistence of vascular remodeling, which is not currently available in the literature. It's also necessary because of the necessity to rebreed the rats in some of our aims. And this is because we need to ensure that the uterine horns are both capable of carrying a pregnancy. As you can see in this is part of the internal validation that is necessary for the study, since realistically the only way we can test the capacity to carry a pregnancy is to have them bred. So the implications of these findings from the study also have the potential to contribute to our understanding of pregnancy-related vascular pathologies. Next. Aim 2 looks at the investigation of vascularization and distension of pregnant and barren uterine horns. Previous studies of vasculature were conducted under conditions where the uterus was ligated at the ovarian end and later stages of pregnancy. Our study is aimed at approximately midterm pregnancy, midterm in the rat's gestation, which is equivalent to approximately 40 days in the human gestation, which is when ectopic pregnancy tend to be discovered. To prevent conception instead of a ligation of the ovarian end, we'll be utilizing a temporarily inserted intrauterine foreign body, as they call them. This is a short surgical procedure that's conducted under isoflurane anesthesia. Next. This was aim 3, but as I said, this is the aim that we have now scrapped, so I'm not going to cover it. Next. So now I would like to share with you the experiments conducted and the findings from aim 1, which address the vascularization, the sensibility of the postpartum uterine horn. Next. So this slide gives detail of the rats. It's pretty much exactly the same kind of information that I've previously addressed. Next. The experimental groups. At 7 weeks, we single house the rats. 8 weeks, we start measuring rat weight, food weight, and vaginal impedance. 10 to 12 weeks, we breed the rats. 13 to 15 weeks, they give birth. 16 to 18 weeks, they're weaned. We have two groups: previously pregnant or virgin, age equivalent. We utilize ultrasound during pregnancy in order to, under isoflurane anesthesia, in order to ensure that both horns actually have fetuses in them. And then we conduct tissue collection at week 0, which for us it's week 0, which is 3 weeks postpartum. And the reason for this is because we do it post weaning. We want to allow the mother to take care of the babies for 21 days, and then that's when the rats are weaned. Week 5 to 6 post weaning, which is 8 to 9 postpartum, and week 10 post weaning, which is week 13 postpartum. Next. Tissue collection involves the collection of the uterus and the vasculature in the rat under deep terminal anesthesia. The measurements that we made is uterine horn length, vein diameter, artery internal and external diameters, and also the mesometrial segmental vessel length. Additionally, we keep the collected tissue and freeze them for further in vitro investigation and experimentation. Next. And now I'd like to address the results from AIM-1. Next. As indicated earlier, we conduct ultrasounds to confirm the pregnancy. These images show fetuses labeled F and the number, as well as a heart rate at the bottom image. As indicated, the ultrasound was utilized to confirm the presence of the fetuses in both horns. While currently the heart rate is not a crucial factor for what we are measuring, it is something that we will be paying increasing attention to in the upcoming experiments as a measure of fetal health. As I indicated previously, we also measure body weight and food weight and vaginal impedance. The first two variables are indicators of health, among other things. The latter, simply put, is an indicator of fertility. Pertaining to the results, our results study, as I indicated with regards to the abortion study, we saw the same kind of thing here. Rats that were virgins, that were never bred, their impedance decreased over time, whereas the rats that were previously pregnant, their impedance remained high because they gave birth, they were pregnant and gave birth. Next. As previously mentioned, I believe I mentioned the placental scars. These are seen when you have a rat that has had a previous pregnancy. These scars are due to hemosiderin in the cells of the reticuloendothelial system. They are concentrated in the area between the longitudinal and circular muscle layer and in deeper parts of the endometrium. So these scars are present in rats that have had a previous pregnancy, but not in virgin rats, of course. Again, they are not necessarily of immediate importance. However, they are and will increasingly be something that we will be paying attention to and considering for our future experiments. Next. With regards to distensibility, the measured length of the uterine horns, a significant difference was observed in postpartum week 3, but not at postpartum week 8, 9. Postpartum in the later years, so 8, 9, and 13. And what you're seeing on the right is an image of a virgin uterus versus the clear you can see the scars, the placental scars in the previously pregnant rat in the bottom image. Next. Related to the arteries, we measured the internal and external diameters, and following a similar pattern to the distensibility of the uterus in both internal and external diameters between the virgin and previously pregnant rats. So we see a significant difference in postpartum week 3, but not 8, 9, and 13. And there was no significant difference observed in terms of arterial wall thickness, which is the subtraction of the internal from the external diameter. Next. In relation to the vein, however, the diameter of the vein in previously pregnant rats was significantly larger across all weeks measured, and that is, the diameter was still significantly larger at postpartum week 13. Next. Similar to the vein, the mesometrial segmental vessel length was also significantly larger in previously pregnant rats across all weeks measured. Next. So to summarize, the vascular muscular level, at the vascular muscular level, our study described both temporary, short-term changes resulting from pregnancy, and these were in the uterine horn length and the arterial diameters, and long-term changes in the uterine vein diameter and the mesometrial segmental vessel length. Importantly, it must be noted that the time over which these long-term changes are still present is equivalent to approximately 8.5 human years. Given that both vascular remodeling and uterine involution occur by smooth muscle contraction, the timeline and observations that we've seen appear to suggest a relationship between the quantity of smooth muscle in the various organs being studied and the recovery time of two pre-pregnancy levels. Specifically, the uterine vein, which contains very little smooth muscle, did not return to pre-pregnancy size during the period studied, in contrast to the uterine artery and uterine horn length. As I indicated in the slide where I described the impedance, our study also confirmed our previous reported findings in the abortion study pertaining to the reduction in vaginal impedance in the virgin rats relative to the rats that had been previously pregnant and gave birth. These findings contribute to our understanding of the long-term impact of pregnancy and our significant relationship in relation to research pertaining to various pregnancy-related vascular disorders, such as preeclampsia as well. Next. The information from these aims, the completed aim 1 and the one in progress, aim 2, will be utilized to inform the steps that we will take in the studies that will follow, addressing the potential method of embryo transfer in the pregnant rats, time of gestation as it relates to success of transplantation, mother's age as it relates to success of transplantation, and then the investigation of the offspring's well-being, looking at neurophysiological, oxidative stress, and behavioral. Next. So ultimately, what should we hope to achieve in these experiments? In a broad perspective, it is hoped that this work will further contribute to our understanding of the complex mechanisms associated with pregnancy and pregnancy-related pathologies. Additionally, we hope that it will provide a basic animal model that allows for continued investigation of surgical techniques that could potentially benefit humans. In addition to that, of course, and pertaining specifically to our project, we hope that it's the goal of these experiments to provide a methodological foundation for a surgical procedure that can be modified and applied accordingly, ultimately in humans, for the transfer of an embryo in an ectopic pregnancy. Next. And this brings me to my final slide. This is just to express gratitude to the Watson Bowles Research Institute, Samaritan Ministries, and TSC, those people that have donated towards this work. My research assistant, Christina Camilleri, also, as I mentioned, Dr. Kara Buskmiller, and their contribution and immense help. Obviously, this is not work that I could do myself. Just that picture on the right, I just want to describe that. That's a multitasking mother. She is nursing her babies while she's sitting on her rear end and eating her food. Next. These are the references, and then finally, my final slide, the next one. I have some information with regards to the lab and our slide. So yes, we can go through the references and go to the slide that has information with regards to the lab. Please feel free to email me with any questions that you may have. Please visit the lab website, look at the work that we are doing, and we would love to hear from you. So thank you again to all of you for listening to me for all of this time. I'm sorry I rushed through all of this, but it was useful and helpful. Thank you.